In this video, we will set up a linear static structural simulation of an assembly in the linear structural validation application, to investigate the displacement and stresses generated in the assembly components, due to the application of a pressure loading. The CAD model is a two-ring assembly, on which an external pressure of 3.5 MPa applied to the face of the assembly bracket, causes the outer faces of the rings to exert contact pressure on each other. The plate holding the large ring is held fixed. The motion of the bracket normal to the applied loading is also restricted. The objective of this simulation is to determine the stresses generated in the two-ring assembly, and the corresponding displacement under the applied pressure loading. Before starting the simulation setup, let us look at the workflow to be followed. As mentioned in a previous lesson, the first step is to save and convert the SolidWorks model to the 3D experience file format, using the methods described previously. If the CAD file is in a different format, it can also be imported directly to the linear structural validation application using the method explained in Lesson 1. The next step is to open the converted file in the linear structural validation app directly from SolidWorks, using the PLM connector, or to launch the linear structural validation application and import the assembly, if in a different format, from the collaborative space or your local machine. Once imported, enter a title for the simulation, and select the simulation type. Then, apply material to the assembly components. The next step is to define the type of contact between the components of the two-ring assembly. In order to restrain the degrees of freedom of the model, apply fixed displacement restraint at the appropriate locations. Then, apply a pressure load to the back face of the smaller ring, which pulls the bigger ring along the direction of the applied loading. This is followed by refining the mesh, to model the stress distribution accurately. The final two steps are to run the simulation, and post-process the results. Here we start with the assembly already imported to the linear structural validation application. Enter the title of the simulation as two-ring_simulation. Under the analysis type, select structural. Click OK. The simulation assistant launches automatically with the application. Now we will start the simulation setup using the assistant. Select the material palette from the materials section of the assistant. Under Filter, type AISI1020. This brings up the material from the list of materials in the library. Drag and drop the AISI1020 material definition onto the larger ring. Repeat the process for the second component. A green tick will appear next to the materials section of the assistant, denoting that the material has been applied to both the components. Next, we assign the contact between the components of the assembly. We will select the general contact option from the contact section of the assistant. The general contact definition is applied in this study to ensure that the components can slide across each other, but cannot penetrate each other. The general contact window opens. Accept defaults and click OK. A green tick appears next to the contact section in the assistant, denoting that contacts have been applied successfully. In this study, we do not have any connections such as the bolt, rigid, spring or pin connectors. Therefore, we skip this section and move on to the restraint section of the assistant. Here we need to restrain the motion of the assembly at two locations. For the first restraint, select the fixed displacement command from the restraint section of the assistant. Select the back face of the larger ring, as shown. And under Translation, select X, Y and Z. Click OK to close the command window. Next, we restrain the motion of the assembly, normal to the directions of the applied load. To do this, select the fixed displacement command again from the restraint section of the assistant. Here we have rotated the model to select the back faces of the smaller ring. select the 4 surfaces shown. From the translation options, select Y and Z, to restrain translation in the direction of the applied pressure loading, which will be shown next. To apply loads to the model, select the pressure option under the loads section of the assistant. Select the back face of the smaller ring component, as shown. Enter -3.5 megapascals under pressure. The negative sign denotes a pulling load. Notice that entering the magnitude of the pressure with its unit automatically converts it to the default units set for the solver. Click OK. The default units can also be changed from the Units option, under the Parameters, Measurements and Units section under Preferences. To do this, select Preferences under Me. Under Parameters, Measurements and Units, select the Units option. Type Pressure, under Filter Properties. Select Pressure under the Units display table. Under Units for Pressure dropdown, select Megapascal. Click OK. This changes the default solver units. In the next video, we will learn how to define and refine the mesh, run the simulation, and post-process the results to analyze the desired quantities.